Hello, everyone. I am Dr. Andre Coronel, and I am the founding member and the leader of the Ateneo Computational Sound and Music Lab. What we do in the lab is that we apply computer science, particularly data science and analytics, on the study and analysis of bodies of music. So these are computer science algorithms that can be used with other data sets like finance and weather and public health, etc. But instead of using those algorithms on those data sets, we use them for the study of multimedia elements, particularly sound and music. This research is important because it pushes the envelope of data science and analytics, artificial intelligence, and machine learning. They're all under one umbrella, and they are pretty famous in their application, in their practical applications in different domains, no? But to actually push the envelope of AI in an interdisciplinary field such as the arts, particularly music, makes it important. It reminds us on why we do the scientific things that we do. Early work in our lab involve simple automated genre classification of music. The AI will learn from a large body of musical input. What's jazz? What's rock? What makes pop tick? Why is this pop? Why is this not pop? Why is this classical? Why is this baroque? And after several inputs, then the AI, the computer, the system, would know what those categories are. And next time you ask the system to categorize a piece of music, it would know. It's artificially intelligent that way. One of my favorites would be students under my guidance. These excellent students came up with a system that analyzes paintings from the Ateneo Art Gallery and automatically produces melodies and harmonies that match the mood of those paintings to enhance the museum experience. The future of my lab, we are sure to dive deeper into both music theory and computer science algorithmic methods, because it's like we've opened the box of wonderful things. So we found out we could do a lot of nice things in the service of science and art since 2015, since the lab started. Paul, we're now dealing with music input as music itself, like in MIDI format. We're dealing with notes as notes, but we're starting to research into this where the music inputs are actually waveforms and compressed files like MP3, wave files, OGG Vorbis. That's why the name of the lab now is Computational Sound and Music. It opens a window of possibilities to include anything that can be heard, not necessarily just musical notes. That's what we're in right now, and my advisors and I are investigating, and we have works in progress, and we're excited. I welcome any budding or aspiring scientist to work with me whenever possible. Maybe we'd cross paths one day, and you don't have to be a musician to actually work on computational music, and or you don't have to really be a computer scientist to work on something like this. If you're both, then that's great, but you can have projects with teams, no? There's like a musician on one hand, there's a musician, and on the other hand, there's a computer scientist, and combine your skills and you can work on something beautiful to actually entice people. I'd like to tell you of the latest project that we have. It's a work with my PhD advisee. As my PhD advisee is right now preparing for his PhD defense, he play actual guitar into the computer. And as he's playing, the system is trying to learn his playing style. By the time he pause, the computer will answer back with a guitar solo that mimics the player's style, a sort of a call and answer type of application. No? It doesn't feel like science when it's done. It's very, very science, but you see the output is quite artistic and entertaining. That's how much fun we can have in our lab.